Hey everyone, Dr. Walker here. Let's go over the first example from v016C. It's called the average velocity of dragonfly. This example is going to give us practice working with vectors when dealing with 2 or 3-dimensional motion, in this case 2-dimensional motion. Problem says a dragonfly is observed initially at position R1. We could also call this R initial if we wanted to. Equals 2i plus 3.5j. 3 seconds later, it is observed at position R2, which would be the final position, RF, equals negative 3i plus 5.5j. What was the dragonfly's average velocity during this time? So it said 3 seconds later. So you should be able to identify this as the time, which we can call it delta t or just t. So let's first write down the definition of average velocity, which is delta r over delta t. And we know that delta r is rf minus ri. And we are given the 2 position vectors, so we just need to subtract them. I'll go ahead and write them all out, but remember that when you're subtracting vectors, you're subtracting the x components separately from the y components. So I'll go ahead and write it all out just to avoid any confusion. Let me actually change colors here. So negative 3i plus 5.5j. And then we're going to have minus, sorry, I'm having fun with my colors here. That's vector RF, and then we have minus RI, so 2I, and then we have plus, and we have 3.5J. All of this is over delta t, which is 3 seconds. So I just wrote them using these colors, so you can see that when we are working with vectors, we're going to do the I, so minus 3i minus 2i, right, which is going to give us minus 5i. And then we have 5.5j minus 3.5j, which is going to give us 2j. And all of this is going to be over 3. And so our final answer is going to be minus 1.67 I hat plus 0.67 j hat. And we do need a unit. You can put a unit after each number right here, or you can just put a parentheses around the whole thing and then put your units as meters per second. So this is the average velocity vector in unit vector notation. And it includes information about the magnitude and direction that we could get if we found the magnitude and direction by using Pythagorean theorem and the inverse tan of the angle, but we don't need to because it just wanted the velocity vector, and this is a vector in unit vector notation, so it is an acceptable and a good answer.